We're using the examples on the previous page to introduce further terminology used in set theory. So we have E represents 0, 2, 4, 6, and 8. L was 0, 1, 2, 3, 4, 5, and 6. And O was 1, 3, 5. So intersection of sets. Remember, intersection is on the formula sheet, and it's represented by this symbol. Remember? Remember I told you that if you have that symbol and you can actually put a line, you could write and, correct? So that means and. Intersection and. So they could do this symbol, they could do this symbol, or they could write the word and. They all mean the same thing. And remember when I said and meant the overlapping ones? So if I said, who in here has on a gray sweater and blue eyes, the only people who would stand up would be people who have a gray sweater and blue eyes. If I said, whoever has a gray sweater or blue eyes, if I said gray sweater or blue eyes, who would stand up? The gray sweaters and anyone with blue eyes would stand, right? So or means either or. If you're an either or group, you list them. And you have to be in both. A lot of people get this wrong. Okay, union of sets. Union follows the U symbol, or. Remember, these two are given to you on the formula sheet. The union of a set is a set A or B, and it's denoted by the A union B symbol. So let's go back to these two. The intersection one says, write the intersection of E and L. So E and L. So they want the intersection of E and L. So what's in E and in L? What numbers? Will? 0, 2, 4, and 6. Then it says, use appropriate notation to write the union of E and L. Union is the U symbol like that. That means or. So in E or in L. Stephen, what's in E or in L? Zach? Oh my gosh. Yes, please. Yes. So you're listing anything that occurs in E or in L. You're correct. So 0, 1, 2, 3, 4, 5, 6, or 8. So does or always have more? Does or always have more? Or have more or and? If you have to be in this one and in this one, or is going to have more. Now, or sometimes doesn't have more. Or would only have more if both sets actually didn't contain the same amount. But if both sets were the exact same set, and an or would be equal, actually. But that's the only way. Other than that, or has more. Okay? Now, disjoint sets. Two sets are said to be disjoint if they have no elements in common. So that's if you go like the elements that are even and odd. How many elements are even and odd? None, right? None of them would be even or odd. So you'd actually have a disjoint. This set would be disjoint. So what that means is if you had even elements, they'd be here. And you had odd elements, they'd be here. But normally, if they wouldn't be disjoint, they'd be together. And you'd have some overlapping ones. Do we have any overlapping elements? No. So this is disjoint. Okay? When you have overlap, then it's not. All right. So let's look at these. Consider the sets A, B, C from class example 2 where U are the natural numbers less than 20. Then the ones that are divisible by 3. So 3, 6, 9, 12, 15, and 18. Natural numbers less than 20 divisible by 5, 5, 10, or 15. Natural numbers less than 20 that are multiples of 6, 6, 12, or 18. List the elements of the following sets. So what is this? Is this and or? And, because if I drew a line, I could write the word and, right? So and is also with intersection. Remember, it's written up there. You don't even need to memorize that. They're side by side. So they could say A intersection B as well. So which elements are in A and in B? A and in B, Miles. Oh, Yeah, 15. 15 is the only element that is in A and in B. Okay? A or B, Jada. What's an A or B? So you listed anything that's in either or. Exactly. So or usually has more, and it has to be in both. Or you list it if it's in any of them, you list it. Okay? Not A and B. The easiest way to always list what's in two elements and or is to actually have the element, the actual set itself written out. We have B, but we don't have not A. So I'm going to list all the elements in not A so I can actually answer this. So not A are all the elements that are in the universal set, so the natural numbers less than 20, but not in A. Okay? So we'd start at 1 because that's the natural number start. So 1, 2, 3 is in A, 4, 5, 6 is in A, 7, 8, 9 is in A, 10, 11, 12 is in A, 13, 14, 15 is in A, 16, 17, and 19. So now that I have not A and I have B, it's easier to compare them when you can actually physically see the numbers that are in each. If you just try and figure out which ones are not in A and in B by just like using your brain and trying to do it, you might miss a number, right? Better if you write it out. So what's in not A and in B, Ryan? 5 and 10? So what's in B and C? B and C, Emma. None. So that would be the empty set. So these two actual sets, B and C, are what? Last definition on the last page. Disjoint. Completely correct. So if you do between two elements and they the and symbol, so B and C, and they result in the empty set, that means that the two sets are actually disjoint. They would have no overlap, right? They'd be two separate circles. If you had two separate circles with no overlap, they would be disjoint. So I want you guys to try this. Try A or C, A and C. Try those two. A or C, A and C. Write the set. So A or C. What's in A? Oops. Or in C? Kathleen. Uh, 3, 6, 9, 12, 15, 18, and 10. Because or is in either or, right? So if it's in A or in C, I list it. I did B. Like a circus. Is the rest right? 3, 6, 9, 12, 15, 18. Oh, these overlap. A and C. Liam. What about the other ones that are in A? Why am I not listing them? I like those numbers too. Why am I not listing them? Because it's and. It has to be in this one and in this one. If it's not in both of them, you can't count it, right? Everyone's really good with the ands, but then they get the ors and they try and treat them like ands as well. It just happens a lot. So remember, or has more. Or if you're in this one, or you're in this one, you get listed. You get counted. You get to come onto the trip. But and means you have to be in this group and in this group in order to come on the trip. Okay? Then it gets a little bit more complex. We're going to go over this one. So I want the ones that are in A and in B or D. This is D. It gave us D. What I'm going to do first is the B or D. Get myself all the elements that are in B or D. and then do the elements that are in A and that. Okay, so I'm going to do B or D by itself first. So B or D in Bud. B has 5, 10, and 15. So I'm going to add 5, 10, and 15 to all of these, right? Because I'm going to list anything that's in B or in D. So 2, 4, 6, I forgot 5, 8, 10, 12, 15, 14, 16, 18. So those are all the elements 2, 4, 5, 6, 8, 10, 12, 15, 14, 16, and 18 that are in B or in D, right? That covers this right here. So now I want the elements that are in A and in this C or D. So in A, we have the options 3, 6, 9, 12, 15, 18. 3, 6, 9, 12, 15, and 18. So 3, nope. 6, 9, nope. 12, 15, and 18. So which ones are in both? 6, 12, 15, and 18, right? Because I only underlined the ones that occur in both. So the answer to this A and B or D is 6, 12, 15, 18. Part 2, I'm going to do down here. A and B or D. Try it out, see if you can do this one. First do A and B though. So what's in A and in B? A and in B, Nick. 15. It's the only one. So in A and B we have 15. Now we want to list what's in A and B or in D. A and B or in D. So if it's in A and B or it's in D, I list it, right? So basically I'm going to list everything in D plus what? 15. So my answer is going to be 2, 4, 6, 8, 10, 12, 14, 15, 16, 18. Okay? Your homework then is following those pages, you're going to do number 8 and 9. 12 and 13. 8 and 9, 12 and 13. Sorry? Yep. So numbers 1 to 7, or technically I guess 1 to 9, 12 and 13. On page 12.